Venus is probably one of the best known planets of our solar system. It is at the heart of many ancient civilizations. Its name comes from the goddess of love, seduction and beauty in the Roman mythology. It is probably for that reason that its symbol is related to womankind. It is true that seen from space, its milky aspect, due to the thick clouds made of ice crystals, nourishes many mysteries and poetry. In antiquity, the Babylonians, Egyptians, Greeks and Chinese astronomers knew Venus and followed its movements. The first modern measurements go back to Galileo, who observed it through his refracting telescope. Since then, a great deal of information about Venus has been revealed. Its orbital period is of 224.7 days. Like Earth or Mars, it is a terrestrial planet. It has a weak magnetic field and has no natural satellites. Venus's special feature is its shape, nearly spherical, but also that its rotation is retrograde, which means that the planet rotates around the Sun in the opposite direction to that of the Earth. Finally, its orbit around the Sun is the most circular of all the planets of the solar system. Here are the orbits of Venus and the Earth around the Sun. Compared to the Earth's orbit, Venus is tilted, so in most cases, these two planets don't cross each other, Venus being either above or below the Earth-Sun axis. However, there is a rare astronomical phenomenon called transit of Venus, when the three solar objects are perfectly aligned. This event takes place when the two planets are in conjunction at the moment when they cross on the line of intersection of their orbital planes. The transits of Venus follow a sequence that repeats every 243 years, with pairs of transits spaced of 8 years, separated by 121.5, then 105.5 years. Venus then obscures the Sun on a very small part of its surface. In December 1639, and following Johannes Kepler's previsions, the transit of Venus was observed for the first time by Jeremiah Horrocks and William Crabtree. His measurements enabled to determine Venus's diameter and the astronomical unit based on the Earth-Sun distance. The astronomers used the parallax method established by Thales. The pair of transits in June 1762 and June 1769 was used to improve the measurements that were taken in the previous century. Unfortunately, the results were uncertain and the calculations not precise. However, the refraction of the rays of sunlight observed by the Russian astronomer Michael Lomonosov enabled to prove the existence of an atmosphere around the planet. The principle of detection, called effect of Lomonosov, is still used by astronomers. In the 18th century, the age of the Enlightenment, the population used to be passionate about the work of these astronomers. People were ready to go to the end of the world, risking their lives to observe the transit of Venus. Today, the technology using space probes has enabled to calculate the value of the Earth-Sun distance with an accuracy of a few dozens of meters. They give a near to perfect value of the astronomical unit and make the parallax method established in the past obsolete. The observation of the transit in June 2004 enabled the scientific community to photograph with precision the phenomenon of the black drop effect. This optical effect is visible from Earth when the disk of Venus is inside the solar disk. In fact, a little black tear seems to connect the disk of the planet to the limb of the Sun, making impossible to time the precise moment of contact. This visual anomaly, attributed to a diffraction phenomenon, is responsible for the miscalculation done in the past, because it prevented the astronomers at the time to determine the beginning and the end of the transit of Venus with accuracy. As for the transit in June 2012, it gives the scientists new opportunities of improving our knowledge of the universe, in particular thanks to the French satellite Picard, which is dedicated to the observation of the Sun. Picard's mission is to improve the knowledge of physical phenomena that govern the functioning of the Sun and study the influence of the solar activity on the climate of the Earth. The transit of Venus will allow to determine the scale factor of the SODISM telescope embarked on Picard, and consequently, the absolute value of the diameter of the Sun, with an accuracy of 200 milliarc seconds. Moreover, from the information gathered by the Picard satellite, the scientists will be able to put into practice in a concrete way the efficiency of their system that detects exoplanets by using the principle of obscuration. They will be able to gauge all their operational measurement systems on the ground telescopes or on satellites like Corot. During the transit, Venus then plays the role of an exoplanet, which is a planet situated in another solar system. This technique of detection is simple. The measurements taken by the SODISM telescope will give the variations of luminosity of the observed star. If a planet passes in front of the star, the telescope will reveal the decrease in brightness. By using the principle of Lomonosov and by using the intensity variations, the scientists can determine the physical and atmospherical characteristics of the planet obscuring the star. The transit of Venus in front of the Sun gives the possibility of studying its atmosphere from the Earth. At the moment when Venus's shadow is in contact with the edge of the Sun, an arc of light, called halo with a variable intensity, underlines a planet on the opposite side. It is the solar light, refracted above the clouds of Venus, that reach a height of 70 kilometers in altitude. This halo is 10 to 100 times thinner than the visible surface of the Sun. Its brightness and extent depend on the density and the temperature of the atmospherical layers the light goes through. From the measurements gathered by the Picard satellite, this phenomenon will be analyzed through different wavelengths. The information given by the Picard satellite will be the most recent measurements established for the study of this occasional event that we call transit of Venus. On the 6th of June 2012, millions of professional and amateur astronomers had their eyes riveted to Venus and the Sun. They were standing in a very precise region of our Earth. And where were you? One question remains. What are we going to learn from the 2012 transit of Venus? Will the measurements taken from the Picard satellite bring us new discoveries that will make science progress?